going to be talking about infrastructure and scaling Arkime. So quick poll, because Slido is where it's at. This is not a quiz. There's no prizes. Sorry. Unless someone has a prize. Your prize is being here. We need to do another user survey soon. Those are always fun. Well, that's pretty cool that there's nobody testing Arkime. Everybody either is brand new or is using it. Oh, there we go. Okay, this is great. So for half of you, you might already know everything, but the other half, this will hopefully be informative.
Which one's correct?
Yeah. Yeah, multiple clusters, yes. That's the correct answer. So let's just start with a quick review around terminology, and you'll hear capture. That's the piece of software that's written in C, so it's amazing. It sits there, it listens to the network traffic, it generates the spy view, sends that off to OpenSearch or Elasticsearch. It's also generating the PCAP and writing that to disk. And it's really the piece that is the input into into Arkime. Viewer is the other side. That's the user interface that people use to look at the data that's in there. That's a Node.js application. We have context, which we just saw the demo of. Parliament is the piece that allows you to manage multiple clusters and makes it easy. It's kind of like your front entry. Wise is the piece that will allow you to enrich sessions inside of capture. So unlike the Kafka piece that we saw earlier, which is enriching the sessions as they flow through after capture has sent them off somewhere, Wise is used when you want to enrich it inside of capture. And then you have OpenSearch and Elasticsearch. We're kind of the database, the magic behind Arkime, and what really makes everything possible. So I'm curious, what extra pieces are people using? We already know no one's using Parliament. It's a good thing Elise is not in the room. Ah, right. I'm always surprised that people say they use Wise because we never get enough questions about Wise, so I'm worried that no one uses it. But it just works that well? Okay. Well, maybe we won't get rid of it yet. I really like the new UI where you can just edit things directly. I hope you guys get a chance to try it out. Nice. Okay, so there's more people using stuff than I expected. That's awesome. So we're going to talk about how you go about architecting your solution with an on-prem solution. Later, we're going to talk about cloud. Chris is going to be talking about our upcoming cloud things. And so some of the things you have to think about is, the size, and if you're going to do multiple clusters or just one large cluster or a combination of both. One of the things I always like to talk about in my slides, and I know I harp on this, so I'm just going to do one slide this time, is a network packet broker. Everybody should be using a network packet broker. If you're not using a network packet broker, you're probably making your lives harder than it needs to be. It really allows you to do separation of duty where your security team is on one side, providing the inputs, providing the packets, and the security team is on, did I say network team? I meant to say the network team is on one side, and the security team is on the other side, receiving the packets. Those are called the tap ports and the tool ports usually. NPBs have lots of cool features. They can load balance, they can filter, they help you scale. You really should be using them. If you pay the big bucks to Gigamon and others, the box can do the deduplication. There are cheaper ones that do not do that. So it's up to you. You also have to decide what kind of tap to use to receive your traffic. There's basically two choices, spans and optical. Span usually means it's a configured port on your firewall or on your switch that is sending the data to your NPB. Optical tap is actually stealing the light as the light flows through. Optical taps are usually the better solution if you can do that. Sometimes they're more expensive. They also have an issue where for every optical port you deploy, you have to have two ports on your NPB, one for transmit, one for receive. Where a span port, you only have to have one span port for the whole switch or the whole router. So sometimes span ports can be a much cheaper way to get started. But eventually, almost always, you should go to optical taps. And I said almost always because there are cases when you don't, and which leads right into my first example. I'm be talking about centralized OpenSearch and decentralized OpenSearch. So centralized OpenSearch deployment might be common if you're monitoring offices. It's a great example. You have offices around the world where you're monitoring. You have a centralized OpenSearch where all those offices are sending their data to. Capture itself lives in each office, but the OpenSearch data leaves the office. And in this example right here, it's monitoring using span ports, 2 firewalls. Many offices are built using HA, high availability, so the firewalls are in an HA pair, so if one falls over, it will automatically go to the next one. Using span ports, sending to the NPB, and you have as many Arkimes that are required to handle that load in that office. I want to do interactive, so if anybody has questions, make sure you tell me. Happy to stop. So what that looks like if you have multiple offices is you have a bunch of Arkimes in each office, and then you have multiple offices, all talking to a central OpenSearch. You have your operator down there on the right that's talking to a central viewer, and that central viewer talks to that central OpenSearch, and then also talks to those Arkimes in the offices. Does everybody know what I mean by central viewer? Who doesn't know? All right, so a central viewer is a viewer that is not directly attached to an Arkime sensor. It's running off by itself. So there's no capture process associated with that central viewer. And the reason you use this is where the operator talks to. Instead of having the operator pick at random or using even a load balancer to pick at random a viewer that's running off on one of these Arkime sensors, it's just talking to one in the middle. This means that you can actually, and I have an example of this in a second, use reverse proxies in front of the central viewer. The central viewer is the only thing doing authentication. It's basically a choke point that you can monitor to make sure this is where I want my operators to go, and no one should be talking to the Arkime boxes directly, no user at least. Only the central viewer is talking to the Arkime sensors. From a security standpoint, this is, I think, very important. This is how you should be running Arkime, unless you're a really tiny deployment. A distributed deployment means that you have your OpenSearch in each deployment of Arkime. And so in this example, we're monitoring a data center. This is using optical taps, and you'll see that this is a single data center with 2 communication rooms. Each communication room is running in an HA pair from each other. There's a core router, whatever, every organization calls it something different, talking to a wave gear or something else. And this is where your optical taps are going to be watching the traffic before it goes to the internet. In this case, the optical taps in COM room 2 are sending the traffic to the NPB2, which then forwards it to the NPB1, which then finally load balances off to the Arkime boxes. So your first question might be, well, why don't you have the optical taps in room 2 just sending to NPB2 or NPB1? Why do you have this NPB2 there? Well, remember, optical taps are stealing light, and most of the time they're only stealing 20%, maybe 30%. It depends on the brand and what you choose, actually. Most of the time, when you're running in an HA pair or when you have COM rooms, there's a long distance between them because you're trying to protect the building getting cut in half for some reason. And the light loss is you're going to lose packets if you actually did that. So you actually kind of need a repeater. And the repeater does not have to be a network packet broker. It's just easier because you can tell your network people to just buy 2 of them instead of buying 1 of them. But you could use a different solution here than a full-fledged NPB for the room 2. But it's basically receiving the light. It's sitting very close to those optical taps because it's only getting 20%. And then it's getting it up to 100% again and sending it down to the other half of the room. The other half of the building. And then this network packet broker is load balancing it to the Arkime clusters. And so you're probably asking, well, why don't you have a set of Arkime clusters from NPB2 and a set of Arkime clusters from NPB1? Well, many times data centers are set up so that you have asynchronous traffic routing where the traffic can go to either of those comm rooms and then go out the building. You want all of the traffic for a particular 5-tuple session to hit the same Arkime box so that it can fully, reconstitute what happened. And so that means you need to get the traffic from comm room 2 to comm room 1, and that's recombined with all the comm room 1 traffic down to Arkime. So what you're probably going to say next, well, what if that bad thing happens and you do get the network split and everything switches to comm room 2? Now you're going to lose visibility. That's true. With this design, you will lose your network visibility if that really bad thing happens. If that really bad thing happens, there's the network team and the security team probably aren't that worried about Arkime. They're going to be like, why is my building in a mess state, and try and fix that. But yes, if you really needed to be able to handle, reverse traffic flow or the building being split, then you might have to set up a second set of Arkime clusters just to temporarily use, or a different path to get to these Arkime boxes. But in steady state, this is the kind of design you want to use. So what if you have multiple data centers? Well, each data center is going to have their own local OpenSearch. Each data center is going to be considered a complete Arkime cluster. And so that means for each data center, you're going to have a central viewer for that data center. And so you'll have n central viewers. You'll also run a multi-viewer. Now, multi-viewer is a little bit misnamed. It's really just a viewer in a special mode that says, I know how to talk to multiple Arkime clusters at once and combine the results. This used to be called tribe mode for Elasticsearch back in the day. It's similar to cross-cluster search. The big difference is we're doing all the smartness for you of combining the data, where if you're using cross-cluster search and some of these other things, it just shoves the data together and it's not clear where the data is coming from and where to go back out. Also, we did this 9 years ago, and so it was before any of those things existed. This is when you might also want to run a parliament so that the user has a kind of a landing page to find all the things that are available. And you can still run WISE centrally, or what some people do is they will run a WISE per data center. It's up to you. Does this make sense so far? Are we going good? Great. I love the estimators. This is one of the first web pages I ever built that I'm proud of, that I think Elise only did a tiny bit of. And so if you haven't used it, please do. It allows you to very easily predict how many machines you're going to need to buy. And it's just at arkime.com/estimators. It's a very simple JavaScript app, and it has very few inputs. The most important input is what is your average gigabits per second that you're expecting to monitor. This isn't peak, this is average, and it's gigabits, not gigabytes. And then the main thing to enter is how many days do you want to store. So in this case, I've said get 9 gigabits per second, and storing it for 14 days. These are the size of my disks. I have 20 disks per machine. There's a FAQ entry on this page that lists all the things to look for when you're buying a box. I know some companies make you buy certain boxes, but if you have the freedom to buy your own box, please look at that FAQ. You get to predict how much TLS you're going to do and what your compression ratio will be. And we just spit out, this is how much space you'll need, and 3 different disk configurations, either RAID 0, RAID 5, and RAID 6. And we tell you this is what you're going to need to buy. So please use this for capture. It's very useful to predict how much you're going to need to spend. Now, where it gets tricky is OpenSearch or Elasticsearch Predictor. This one has the same input. It needs to know 9 gigabits per second. Your retention, you should almost always do a longer retention for your OpenSearch versus PCAP, just because the metadata takes up less space and it can be more useful. Having more PCAP than OpenSearch, I don't think makes sense at all, because there's no easy way to access that data once it leaves the OpenSearch retention. But sometimes it does happen. The most important thing on here, besides these 2 default ones, is replication. So it will default to 0 replicas. You may want to do 1 replica. It just depends how important your data is. And it's going to output a whole bunch of things. The most important being, the different number of hosts that you'll need. And it has 3 different kind of patterns that it's going to output for: average, high DNS, and pathological. What you should buy just depends on how your company works when it comes to budget and what you expect. So if you're expecting, and you can always add more open search boxes. It's not hard to do. It pretty much is just plug them in and install the software and it works. But if you're at a company that has budgetary requirements that are complicated, i.e. you can buy once a year, once every 5 years, if you can afford it, you just go for the pathological, because then you're going to be safe, right? But if you can't afford it, then you can back off and figure out what the right solution is. My personal recommendation is going for the high DNS grade 5. That's where I always tell people to start. But some folks would rather run replication, several replications, and go for all disk RAID 0. That will probably be a little bit faster and search results. Or some folks want to do 0 replication but want to do RAID 6 just so they have the safety with the data. Unfortunately, if a box goes down as opposed to a disk, if you don't have any replication, you've kind of lost that index. So usually you want to do replication of 1 and go right here in the middle at 1 disk extra for RAID 5. That's my recommendation. It's a good place to start. If you have a company that says you're buying today for the next 5 years, do pathological, and then you'll be good, just because it should never be worse than that. Make sense? Cool. The next big thing to think about is authentication and authorization and how you're going to do that with your cluster. We support a bunch of different things, a bunch of different ways to do it, now including OIDC. So you can use your favorite OIDC provider with Arkime. If you don't use OIDC and you have some kind of enterprise single sign-on, really the best and easiest solution is a header authentication with Arkime. That's where you use a reverse proxy. Your reverse proxy is responsible for talking to your enterprise single sign-on system. It's going to set a header, an HTTP header, and Arkime will know how to look at that HTTP header and figure out what user it is. Authorization is different. And that's basically who can use it. Currently, we only support built-in authorization. Now, you can automatically authorize people as it sees new users, and I'm going to go over that in just a second. But once a user is added to Arkime, it comes the authorization comes out of the Arkime's database. One thing that a lot of people don't know is that you can have a users database that's shared between all your Arkime clusters. So if you have 5 Arkime clusters, you can have all those Arkime clusters use the same users database. So you only have to deal with your users' passwords and stuff once. So we always recommend doing that. And that's what that looks like in the distributed deployment we talked about earlier. We now have just it just has to be, tiny instances, because it's really only going to have the users database, the shortcuts database, and maybe the views database is all in there, all tiny. And everything is going to talk to that for authentication. And all you have to do to your config files is just add this users Elasticsearch setting that points to your cluster. Are folks using users Elasticsearch? You're using shared ones. Are folks not using it? People don't want to answer. I need Slido. Okay, now I'm going to go over some important auth settings real quick that people get confused about. Number 1 is password secret. I want to get rid of this for Arkime 5 because it causes endless confusion. Basically, it's the password that is used to encrypt the hashed version of your password. So that's nice and confusing. The reason this even exists is back in the day, Elasticsearch was wide open and had no security whatsoever. And so we had to overlay security on top of it. And so we encrypted stuff and that password was shared. The other thing that confuses people is the HTTP realm. Because we support HTTP digest, there's this digest realm piece that's in the algorithm. You can see the algorithm down here of how this crazy hashing works, but this is what was required to make digest work. For v5, I want to get rid of HTTP digest. It's time to move on. And we'll talk about that in a little bit. But yes, password secret, just set it across all your instances the same, and that's what's being used to encrypt things. Yeah. Right. If it's different on two different boxes, you won't be able to log in on the box that it's wrong on. So. Taylor, you've been reading my slides. So for system to system, we have another password called server secret, and that's what's used to encrypt the data that's sent between instances. So an important thing that I should have said right here is once you set password secret, you can never change it unless you want to re-enter your passwords for every single user. So this is like forever. But again, it's encrypting the hash of a user's password. And it's really not necessary anymore because OpenSearch and everybody now has HTTPS. I mean, this was back when Elasticsearch didn't even have HTTPS. So,
you know it's old because you did that file.
Right. So, yeah, you used to have to use, I can't remember what the plugin was, Security Guard. SearchGuard. SearchGuard, yeah. User IPs we talked about earlier. This is how you can control who can authenticate. And username header is another variable that's disgusting. We're going to be changing it for v5. It's basically overloaded. It's either what mode you're using or the header to use for reverse proxies. So if you set it to digest, it's going to use the digest mode to authenticate. If you're going to set it to OIDC, it's going to use OIDC. Anything else is what it's going to use to look for the header. Really, this should be two different variables, and it's on our list for v5. This was a contributed feature, and it's kind of awesome, but kind of scary at the same time. You can auto-create users from the headers that come from your reverse proxy. So instead of having to write a script that auto-adds people and syncs things from, I can't remember, Office 360 or whatever, you can make it so that if Arkime sees a new user and they're allowed to log in, and there's a way to say how they're allowed to log in or not, we can go to the headers, fetch random data. Like here we're fetching the user ID is going to be the email address, and the username is going to be this exported name thing. And you can create the user on the fly, and it will create the user and stick it in the user database. Lots of companies use this who have enterprise single sign-on and don't want to write a syncing program to sync with their database. Yes, this is very important that you have a reverse proxy. You would not want to use this if you didn't have a reverse proxy and anybody on the internet could connect to your system, because then they could just start creating users, which would be pretty cool. But yes, you need to secure your security tools. Okay, we're going to jump into capture tuning. Yes. Right. So, not really. So Eli's question was, have we thought about doing a better way instead of this stupid way and making it so that we actually use an IDP or something similar? Yes, we've thought about it. The first step on that path was supporting OIDC. The reason we never did it in the past is because I was adamant that we would only ever support digest, header, anonymous, and that was it. That we as a team of one or two did not have the time to deal with all the people that would say, why don't you support SAML? Why don't you support OIDC? Why don't you support this thing? Why don't you support that thing? Just use a reverse proxy, have it do everything, and then once you make it past the reverse proxy, we know that you're okay. So we are starting down that dangerous slippery slope of letting other authentication methods in. We've gone with OIDC first. Maybe eventually we'll do SAML. I don't know. It's just there are so many variables for SAML. It's just it's crazy. Nice. I can't wait. But yes, it would be awesome to do that. Love to do that. If there's a way we could get more resources to work on this kind of stuff, that would be awesome. Or if you work for a company that wants to donate that code, would love it. Was anything else? Did that answer your question?
Yeah.
Okay, capture tuning. There's lots of variables that you can use to control. I hope everybody uses the settings page where we document all the settings. That's every time someone posts a question on Slack, it's either, why is my Arkime cluster not working, is the FAQ answer, or the settings page has your answer. So start with those two places, please. It's awesome. And as you already learned, that all is in GitHub. You can make changes and make it better. If you think my writing stinks, which it does, please, update it. I would love people to say this bad English, I make it much better, and that would be awesome. So here's some important things to think about if you need to increase your performance with Arkime. It's kind of silly, but one of the first things to do is to turn off the magic mode. libmagic is terrible. It uses a lot of resources. For every single call you make to libmagic, it recompiles all of its regular expressions. It doesn't cache that it's compiled them before. And so it's just terrible. What we've done is inside of Arkime, we have built in about the top maybe 50 libmagic results, like GIFs and zip files, et cetera, et cetera. So we will catch the most common things. And by default, if you set it to, I think it's both mode, which is now the default, it will always use our code first before calling libmagic. So we're trying to help some, but it's still, you shouldn't use it on a high performance place. Using AF packet, that is the best way to get packets. We're going to change the default to using AF packet for v5 instead of using libpcap. You can fool around with the block sizes and the number of threads. Please read the comments about how to change these values. I set the number of threads to 32, and it has not improved my performance. Well, every time you increase those threads, it's actually going to be using more resources to talk to OpenSearch, to talk to the disk. It's more than just processing the packets in those threads. It's increasing everything. And so unless you have a really beefy machine, sometimes you can make things way worse by increasing these numbers. And this one I've documented both in the sample config file and the web page, trying to get people to read. Reading is hard. There's lots of ways to reduce how much packets you're saving to PCAP files. We have rules, Arkime rules. We have a gallery at arkime.com/rules. Love people to go look at them and submit new ones. You can just drop these in. I'm going to have some example rules in just a second. Make sure you enable deduplication and compression. We're recommending people use zstandard. gzip is still currently the default, but zstandard uses less CPU.
This is for
Yep. Right, so the Arkime rules are about dropping the packets or specifying how you deal with the packets as they flow through capture. And so there's two main things you can do. You can either say, I don't want to process these packets anymore for this particular session, or you can say, I don't want to save this session to OpenSearch. So you're saving space both on OpenSearch and on disk. So here's two very simple rules. One is that everybody should have enabled, and we need to put in our defaults. Basically, this is saying in its cryptic language, if it's TLS, SSH, or quick, only save 20 packets to disk, because after 20 packets, it's pretty much worthless. If you really want to, 30, if you have a lot of GRE or whatever going on, but after that, you don't need any more than that. And one of the number one questions about this is, in the UI, it still says I saved 90,000 packets. Don't trust the UI. What the UI is showing you is how many packets were in that session. It is not showing you how many packets were saved to disk. Currently, the only way to see how many packets are saved to disk is to actually download the PCAP. So when you download the PCAP and look at it at Wireshark, they'll say, oh, there's only 20 packets, even though the UI says there's 90,000. There's two ways to solve this. We could add a new field that says how many packets are saved to disk, or we could change the current one and add a new one, which is how many packets there were.
self-signed certificate. And if we had dropped the TLF traffic, log in, we're actually able to go get it from the
Right. So the answer is, the question is for writing rules, can you detect if it's self-signed or not? I'm trying to think if that is one of the cert fields that we currently have. I can't remember. I know we do have like who the issuer is and stuff like that. And I don't remember if that has in it that it was self-signed or not. I don't remember. That is a great idea. If you could open an issue so we don't forget. Or send a pull request. Yes, either way. And the important thing about this first one on the left is the when is field set. And that's basically saying when the protocols field is set to one of these three values, set the max packets to save as 20. Where the one on the right is a little bit different, where it says before final save. And that's saying right before I save this to OpenSearch, run the rule. And what this rule does is it says if there is a SYN and a source packet count of 1 and a destination packet count of 0, don't save it because it was a SYN scan and we don't care about very simple SYN scans. Did you have a question, Chris? Okay. Let's talk a little bit about whether or not you should do encryption of your packets. I think if you can, you should. There's two different ways to do it. You can either use Arkime for your encryption or you could use disk encryption. There's pros and cons to both of them. It's up to you which is easier. The one reason I like Arkime encryption better is if someone logs onto your box, they still can't access the PCAP files without some tooling. With disk encryption, if they get on your box, it's not, they can just touch the PCAP files as if they were PCAP files. The one reason disk encryption is better is all of the key complexity and managing the keys and rotating the keys is part of the disk encryption and not part of Arkime. So it's not a job of the Arkime operator. It's either a job of the ops person that runs the box, or it could be part of your TPM chip. It could be however you want. And so it offloads it to either the computer itself or the people running the computer as opposed to the people running Arkime. If the people running Arkime are the same people as who are running the computer, then you got to decide what's right for you. So there's two different ways to do it. The other thing is disk encryption probably is going to be like FIPS or whatever, where the Arkime one has not gone through anything. Anybody using disk encryption? Nice. No. No. Yeah. Okay. I've never actually used it, so I don't know. I don't know how painful it is. Mark knows how painful it is. Talk really quickly about whys. When you want to put whys into your system, you have to decide where it should live. If you're running lots of separate clusters, you might want to whys per cluster. If you're running just one big cluster, you could have it centralized. The big thing about whys is that it does caching at multiple levels. When whys talks to the sources for its data, it will locally cache it no matter what. You can also configure Redis as a cache for it. This is especially useful if you have many whys servers. If you configure Redis for it as a cache, they will all share it. And so only one whys server has to go to the source, look up the data, and then it will stick it in the Redis cache. All the capture servers are also caching the results from whys. So whys things are cached everywhere, and whys was built for cacheable queries. A lot of folks want to do things that are not cacheable with whys, like one person requested doing 5 tuple lookups. That would be super unique. Not the best thing for whys, but it might be a great thing for Kafka. Once you get everything running and working, I recommend you check out the ES admin tab under stats. You have to be a super user or Arkime admin user for it to even show up. If you're ever having Elasticsearch or OpenSearch problems, the first thing you do is you go to this tab and hit these top 4 buttons, just one after another. And it tries to fix the 4 most common issues with Elasticsearch for you. Retry failed is just a random call that'll tell it to just retry stuff and see if it figures it out. So do that. Yeah, it's like you hit that and it tries to fix things. You hit flush and that tells OpenSearch, hey, if there's anything hanging out, just try and flush it. You hit unflood because if you don't know, I'll get to flood mode in a little bit, but Elasticsearch and now OpenSearch added this wonderful, terrible feature that just shuts down indices when it starts to run out of space. So then everything starts failing and you're like, why? And then you still don't know. And then you free space, and sometimes, I don't know why, even though you're above the unflood situation, it doesn't unflood itself. And it's just like, I refuse to write to disk. You just hit this box and it will tell it you're wrong and it will unflood it. And then clear cache just goes and tells OpenSearch to free all of its caches. So when you're having problems, just hit these 4 buttons. I probably should make one button that says the easy button, and it does all 4. But this way, you can pretend you know what you're doing by. Yeah, hit all 4. All of the above. And this works for all of the things. The most important thing, and this page actually says on it, and we didn't put it in the screenshot, that you can destroy the world if you change these values. So this is a very, very dangerous page. And just be careful with it. But the other thing to always look at is what your disk watermarks are set to. A bug in an OpenSearch is it makes these decimal values that are like this long and fills the whole screen. I need to file a bug report about that instead of these nice values. I suggest changing it to percentages if you don't want to deal with it. But you can also go in here and just change it to tiny values, and it supports any kind of byte value. And here we have them just set really low. I think they can't be the same value, and they can't be some percentage and some non-percentage. They all have to be the same unit. But a very important thing is to go in and change this right away, because it's almost always, if you've never set it before, set incorrectly. It's usually set, I think, by default by maybe 10% of your disk is where the flood watermark is. So you're wasting 10% of your disk. At least that's how I look at it. The rest of these, you really should only change if you know what you're doing. The rebalance and recoveries one, if you change that to a bad number, OpenSearch will just take indices and bounce them back and forth between 2 nodes all day, forever. So by default, just leave them 2 and 3, or whatever the defaults are. And there is a little button you can hit, which I don't know why it isn't showing up properly, but that will reset it to defaults. The one other one here that you might want to play with is recovery max bytes per second. Whoops. You might want to change this to a higher value than what the default is. Again, you got to be careful with this. If you change it too high and you're doing like a hot-warm cluster, it will spend all of its network moving from hot to warm and start dropping all of the incoming requests. And then all your writes will start failing and bad things will happen. I think the default is 40 megabits per second, which is too low. 450 might be too high. I don't know what the right number is. It depends on your network. And so this is one that's useful to change. The higher the number, faster recoveries will be if you have a full outage and you want to recover. So it is useful to raise it at times, but you just got to be careful. And what else is useful in here? You can actually fool with some of the things that db.pl sets if you want in here, or you can just go back and use db.pl. But definitely use this tab, these top 4 buttons, if you're having OpenSearch or Elasticsearch issues. Sweet, and that was the presentation. And these, I guess these are the questions from before. How do I, I feel like that. There's still no cake. Has Arkime gotten Frederick? No. Someone has to pay for that. Using DC latency, I answered that. MPP that is affordable.
key bells and whistle. Your
So I always recommend that folks, if they're already using Aristas for other things, start with Aristas. Aristas are almost always the cheapest solution because they don't have specialized network packet brokers. Instead, their network packet brokers are just their switches running in a different mode. They have almost zero features. And so unless you get the new ones that integrated whatever.
dollar
Yes.
every bell and whistle.
Right. And so what Arista does have is they bought Big Switch, I think, last year. And they try and sell it kind of like Gigamon where they're upselling you. Instead, you go and look at their straight switches and they have a base model that I want to say their feature is called, it's not DAF. I don't remember what it's called. Because of the D. It just does network packet broker type stuff. After them, you start looking at the Ixias, Big Switch, I guess driving back and forth, Gigamon, and others. And then there's some that are even more expensive.
What's the lead time?
I've heard if you want the big boxes, it can be months to years. I don't know. This is also why I like the Aristas. If you're a Arista shop, you probably already have one of the boxes because it's the 7150s, the 7200s, and the 7500s all can be run in this mode where it's just a special mode. You're not having to buy a new specialized switch. And so a lot of these ones are used for TORs or basic tree spine. So, other questions? Cool.
One addition, I hope this doesn't show. Is there an option to hide EES credentials in the capture logs?
Yes. So the question was, can you hide the EES credentials in the logs? Yes, that was added a while ago where you can still leave it in the URL if you want, or there's a new variable called, I want to say ES basic auth that you can set the variable in. And even in that variable, you can now do the base 64 encoding if you want to hide it from just obvious looking. So if someone looks at the config file. Same for the users Elasticsearch. There's a users basic auth or something like that. Users Elasticsearch basic auth. Other questions? This is your time to talk about deployments. I love talking about deployments, at least on-prem. I miss it. Do it. Capture all the data.
If you have multiple nodes running off the same Elasticsearch database, and you've got all your all of your flags supposed to be talking to it. Node. Is there a particular reason you imagine that you're opening a session for a remote node that it just sits there and spins all day not throwing any errors?
Yes, you don't actually have your FQDN set correctly.
Now, see, when they weren't set correctly, it'll complain.
Okay.
So then when I change them, stop complaining about it.
So there is information in the FAQ about this. Which diagram? I don't know what the best diagram is, but basically what happens whenever an Arkime node starts up, it writes to OpenSearch, this is my FQDN,
Right.
and this is how you reach me.
Fun to deal with when everything is
Right.
behind.
And so there's a command line option to capture where you can say, don't trust the OS. This is what you should tell viewer. It's the dash host option to capture. And so it writes that to OpenSearch so that when your central viewer comes along and says, I need to talk to Arkime node 1.1, it looks it up in OpenSearch and says, what's the FQDN? And it knows how to reach it. So if it's not working, that is almost always the reason. The other reason is we do use the config file first. In this config file for central viewer, you can say to reach Arkime 1.1, this is the URL to use. And so if you accidentally have put in your config file this URL,
So
it will ignore the one here.
Oh,
The one that's in the config file trumps everything because it's assuming that your config file is what you want to use. And so that is one way to fix it in a central viewer mode is you could go through and list for every single node you have, this is the URL to use to get to it. Ignore everything else.
One other thing that was helpful to us that we've wanted for a long time and showed up in the XES 6 and higher software versions is the ability to like load balance on the tool port side where we've got some much older hardware with much newer hardware in certain locations. Not if we try to send even traffic through all of them, the old boxes would kind of stress that.
Cool. Okay, great. Any question? Yeah. Okay. Okay. It can be used for that. It depends exactly what you mean by not saving everything. If you mean you really don't want to save the packets, then yes, you can use rules for that. If you mean you need to scrub the packets, there is a plugin called, I think it's called Scrub Spy, that will go through the spy data and scrub it. So we had, I can't remember if it was a credit card company or a healthcare company that didn't want credit card numbers ever stored. And so they actually wrote a little script that could go through and scrub from the URLs and still save it to the data, to OpenSearch, just without the credit cards and some other data they didn't want to save ever. Because they were capturing after all of their encryption. They just wanted to make sure that it was never stored, right? And I guess some people put their credit cards in the search box, right? You go to your visa.com and typed in, I'm not saying it was Visa, but whatever. You go there, you type in your credit card number in some search box and it gets saved to something. They just wanted to make sure that never could happen. I don't think it was their normal, payment processing system that was storing the credit cards. Yes. Sure. Yeah. Mm-hmm. So the question was about enabling compression between Arkime and OpenSearch as we're sending up the bulk data. You should enable that. It's going to lower the amount of network traffic you're sending it up. And there's actually lots of papers about how when it's in memory, assuming Elastic and OpenSearch implement it correctly, when it's in memory, it's in the L1 cache or blah, 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 and it's actually faster and it uses less space. And it will actually help. Yeah. 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 Yeah, definitely for the part where it writes to disk compressed, that's enabled by default now. I think you can mess around with the codec. You shouldn't. Yeah.
We're looking at like switching to
Yeah.
standard to Intel distributed.
Yeah. So we're talking about two different things. When you write to disk in Elastic, definitely leave that on. You were talking about going from Arkime over HTTPS. That I think you should enable. I should probably add that to my list of defaults we should change. We already do I can't remember. So, is it? Okay, great. I don't remember anymore, but If it's not, we should. And we already have logic in there that if it's smaller than, there's some study like 33, maybe it's 300 bytes, don't compress it or whatever. So we already have that same logic that everybody else is using. Yes.
One of the suggestions for deployment, we haven't actually implemented this yet, but it's in our backlog, have a dedicated separate Arkime cluster for storing the results of investigations.
Yes.
This was born from an incident where we did some searches and we found some packets, and those packets were right on the cusp of being rotated out of Elasticsearch or off of disk or something. So we wanted to be able to store the results of that search into another cluster for long term.
Yes. So Arkime, I haven't talked about it at all, already supports the concept of investigative clusters. And there's two, look at Owen celebrating. There's two ways to get data into your investigative cluster. One is through periodic queries, where you can tell a periodic query to send whatever the match is over to the cluster. The most common way to do this is to look for tags. So if an operator goes in and tags something, you can have a periodic query that's constantly looking for that and sending it over. If you know that there's a bad actor on a particular IP, you could also automatically send it over to the investigative cluster. And then there's a manual process on each, where is it? I think it's in the action menu of each session. You can go there and just say send to investigative cluster. You can have as many investigative clusters as you want. And so, we talked to some folks about having an investigative cluster for incidences and some for insider threats. And for some reason, the insider threats and the IR team never shall meet at some companies. And so they each wanted their own.
Because the IR team is the insiders.
Yeah, probably. Yes. Okay.